It started with a selfie. People uploaded a normal photo and typed a simple request: turn me into a tiny collectible toy figurine in a box on a shelf, and a little plastic version of them came back, photorealistic lighting and all. Then it spread, millions of people doing it to their own faces overnight, and Google's Gemini app shot to #1 on the download charts. The feature behind it had a strange nickname: Nano Banana. So here is the puzzle this whole video is about. Why did a creative image feature, not a benchmark score, move millions of people in a single week? And what is actually happening inside the machine when you talk to a picture and it changes? That is the story. What this thing is, why it matters beyond one trend, what it can do, and the part most explainers skip: how it really works. First, untangle two names that get mashed together. There is Gemini 3 and there is Nano Banana. They are related but not the same. Gemini 3 is Google DeepMind's flagship model family, launched in mid-November of 2025. It is the brain built for reasoning, for understanding text and images, and for carrying out multi-step tasks on its own. Sundar Pichai's framing was that it moved from simply reading text and images to, in his words, reading the room. Nano Banana is narrower. It is the image generation and editing capability that lives inside Gemini. Now the single most important fact to get right: Nano Banana is not an official product name. It is a nickname, a code name. It first showed up anonymously on a public model ranking site in mid-August 2025. People noticed it was unusually good, and the playful banana label stuck. The official name underneath is Gemini 2.5 Flash Image. So the big model news was Gemini 3. The thing that went viral was the image feature inside it. The versions matter, but only a little, so here is the map once. Then forget the labels and remember the idea. Step 1. Nano Banana, the original, that 2.5 Flash Image model from August. And notice the date, because this is where people go wrong. The original came out before Gemini 3 even existed, so calling it a Gemini 3 product is simply incorrect. Step 2. Nano Banana Pro, officially Gemini 3 Pro Image, announced about 2 days after Gemini 3 itself in late November. This is the one actually built on Gemini 3's reasoning, and it added higher resolution, up to 2K and 4K, plus legible text in many languages. Step 3. Nano Banana 2, officially Gemini 3.1 Flash Image, arriving in early 2026, pitched as pro-level quality at faster, cheaper speed, and rolled out as the default image engine across Google's products. 3 stepping stones, each better than the last. The names will keep changing, so I am going to teach the concept, not the catalog. Now the actual subject here is not a spec sheet. It is a cultural moment. For years, Google's chat assistant was seen, fairly or not, as the runner-up to the most popular chat app, and benchmarks did not change that perception much. What changed it was a creative feature people could do to their own face and instantly share. The photorealistic figurine trend, and the wave of edits after it, pulled an enormous number of people into the Gemini app very quickly. And that is the lesson hiding inside the fun. A shareable, personal, low-effort creative act spread faster than any leaderboard win ever could. So as we go, hold 2 questions at once. The mechanical one: how does one model both understand and create an image? And the human one: why does a feature and not a benchmark actually move millions? Both answers are the point. Here is the durable idea, the thing that outlasts this product. For a long time, getting an AI image meant 2 separate systems in a relay. You talked to a chat model, and it handed your request off to a completely different image-making program, strangers passing a note. The shift Nano Banana represents is called native multimodal generation. Instead of phoning a separate image app, a single network is trained on text and images together from the start, and produces the image itself. Google's framing is that the model uses deep language understanding to capture the nuance of your prompt, and makes images that follow real-world logic thanks to its reasoning. And this is not a Google quirk. It is an industry direction, the same move that shows up in other frontier systems, like the native image generation built into a leading rival's model. The field is pulling image making inside the brain, instead of bolting it on the outside. And why does that matter so much? Because of something called a shared representation space. When generation happens inside the same network that reasons about language, the model treats three things as the same kind of stuff: your uploaded photo, your written instruction, and the image it produces, all in one common internal language. So when you say, keep her face exactly, but change the season to winter and add a caption that reads correctly, it can do that in one continuous conversation because it actually understands the picture, not just a file it received. Stitch that out of a chat model plus a separate image service, and it gets awkward fast, because the two halves do not share a mind. So what does that buy you concretely? The headline is conversational iterative editing. You make an image and just keep talking. Now make it night. Remove the car. Give him a hat. Each turn, the model holds onto the same image and changes only what you asked. The old way often meant generating a fresh picture from scratch each time, and your subject would subtly shift, a different face, a different room. Here the edit lands surgically. That same shared understanding powers a cluster of abilities older tools fumbled. Consistency, holding a character or object steady across many edits, keeping resemblance for several people and fidelity for over a dozen objects, so you can build a series of frames. World knowledge grounding, laying out a real infographic or a correctly structured diagram. The water cycle say, properly labeled, not just pretty. Studio controls, lighting and camera and color, plus high resolution. And it can weave generated text and pictures together in one flowing conversation. One more capability, the image text, deserves its own moment, and we will get there. Now the heart of it, how does this actually work? To feel the shift, see the old way first. Picture two separate boxes with a wall between them. On the left, a chat model. On the right, a standalone image generator. To make a picture, the chat model takes your words, turns them into a vector, a list of numbers capturing the meaning, and throws that over the wall. On the other side, the classic image generator uses a process called diffusion. It starts from pure random noise, a field of static, and step by step removes the noise, sculpting it toward a picture that matches the vector. Exactly how diffusion turns static into a photograph is a beautiful story, and its own separate video, so we will not unpack it here. What matters is the wall. The image side never truly understands your picture as a thing. It just receives a description and renders. Nothing meaningful flows back. So real conversation, real consistency, real editing, all of it is hard, because the two halves do not share a mind. Here is the hero moment of the whole video. Take those two boxes and collapse them into one. That is native multimodal generation. Instead of a chat model and an image app separated by a wall, you train a single network from the very start on text and images together, so that to this one model, words and pictures are just two flavors of the same underlying stuff. The wall dissolves, and now everything we talked about falls out naturally. The model carries context across turns because it never handed your image to a stranger. It keeps a character consistent because the character lives in its own understanding. It renders correct text and accurate diagrams because the same reasoning that knows facts about the world is the thing drawing the picture. The reasoning does not stop at the wall and pass a note. It flows straight into the image. That fusion, two boxes becoming one, is the single idea this entire breakout rests on. But what is going on inside that one box when it makes a picture? Here is the standard vocabulary carefully. A language model makes text by predicting the next word, one piece at a time. Modern native image models broadly do something similar with pictures. First, an image is broken into a sequence of small units called visual tokens, using a learned image tokenizer. Think of it as a dictionary, sometimes called a codebook, that turns patches of an image into compact numerical summaries, what researchers call latents, that act like symbols, the way words are symbols. Then the model generates those visual tokens one after another, predicting the next piece of the image much like predicting the next word. That is the term to know. Autoregressive generation, building the output step by step, each step conditioned on what came before. Finally, a decoder turns that sequence of tokens back into actual pixels you can see. The clearest publicly documented example of this pattern comes from a rival lab, which built its native image generation right into the same model that handles text, and described it as generating images autoregressively, the next token way. So the picture is built a bit like a sentence, then painted. Now two crucial honesty notes, because this is where confident explainers go wrong. First, autoregressive versus diffusion is a false choice. The documented pattern in frontier systems is usually both together. An autoregressive backbone produces a kind of semantic plan, the layout and meaning, and then a diffusion decoder paints that plan into final, high-quality pixels. The write-ups on that rival system describe exactly this: one unified model trained with a word prediction loss for the text and a denoising loss for the image patches. So the win is not one technique beating the other. It is combining the planning and instruction following of the autoregressive part with the visual quality of the diffusion part. Second, the big one. Google has not published Nano Banana's exact internal architecture. Outside analysts have inferred designs and slapped technical labels on it, but those are educated guesses from watching its behavior, not a confirmed spec. So here is what is safe to say. It is natively multimodal, Google's own word, and the broad industry pattern is autoregressive planning plus a diffusion decoder. The precise internals of this specific model are simply undisclosed. Anyone who says they know exactly how it is built is guessing. Two payoffs of doing all this inside the reasoning model. First, legible text in the image in many languages. Early image models were notorious for garbled, dreamlike lettering. They painted shapes that looked like letters without spelling words. The newer models reason about the words first, so a poster or a label comes out actually readable across different scripts. That is a perfect example of progress, not a permanent flaw, a problem that got solved. Second, the responsible part, and it is built in, not bolted on. Every image these models make carries an imperceptible watermark, a DeepMind technology called SynthID, woven into the pixels themselves, detectable by machine, and designed to survive edits and screenshots. The newer images also work with a cross-industry provenance standard called C2PA, backed by a coalition of major technology and media companies. You can even upload an image to Gemini and ask whether Google's AI made it, a check used tens of millions of times. To be honest, the free tiers also stamp a small visible sparkle mark, which top subscribers can remove. The point is traceability, because when anyone can make a convincing image in a sentence, knowing where it came from suddenly matters. So how does this stack up? Two comparisons kept apart. On the brain, the model family. At launch, Google reported leading scores across a range of tests, topping a popular human preference arena and posting strong numbers on hard reasoning and coding evaluations. But hear the wording. Those are vendor-reported numbers, the company grading itself, and such scores are contested and shift constantly, so treat any single figure as a snapshot, not a law. On the popularity question, did Gemini overtake the leading chat app? The honest answer is no, not in usage. The viral surge did briefly push Gemini to #1 on the download charts, knocking the rival to second. But downloads are not usage. By how much people actually use them, the leading app kept a real lead, by some measures roughly 2 to 4 times bigger, depending on the metric and the month, and its users came back far more often. And the figures floating around are not even the same window. One in weekly active users, the other in monthly, so any clean overtaking claim is sloppy. Call it what it was, A viral surge that closed the gap, not an overtaking. Yet the momentum was real, Gemini's reach growing several-fold over a year. And on images specifically, separate from the chat rivalry, the Nano Banana line is widely regarded as a genuine category leader, especially on that crisp, legible in-image text. I keep that hedged, because image quality is taste-dependent and rankings shift weekly. So how do you use it and what does it cost? For everyday people, it lives in the Gemini app and increasingly in search, the visual lookup tool, slide and video creation, and ads. For developers, you reach it through the Gemini programming interface, the AI Studio playground, and the enterprise cloud platform. The skill is almost funny in its simplicity. Describe the edit in plain words, upload a reference photo or two, keep iterating, pick your resolution. On cost, here is the durable shape, because exact prices change too fast to memorize. Casual image making is free or low friction in the app, which is precisely why the viral hook worked. Heavier use, the highest resolutions, and the watermark-free experience sit behind paid tiers. Free to start, pay to scale. Now the limits told straight. Almost every number in this story is volatile, and the sources must not be blended. The dramatic first-week figures are Google's own claims. The user milestones come from Alphabet's earnings. The App Store ranks and the usage gap come from independent measurement firms. Mixing a company's claim and an analyst's measurement into one sentence, as if from the same source, is how misinformation gets made, so prefer the orders of magnitude. Millions of users, hundreds of millions of images, and provenance is real but not foolproof. Watermarks can be cropped or stripped with effort, and instant photorealistic editing genuinely lowers the bar for convincing fakes, which is exactly why the traceability stack exists. Before we land, let us puncture the 5 biggest misunderstandings quickly. 1. Nano Banana is Gemini 3. No. The original is the earlier 2.5 Flash Image and it predates Gemini 3. Only the Pro version runs on Gemini 3. 2. It is a separate image app glued onto Gemini. No. The whole point is that it is native, one model that both understands and generates, which is exactly what makes conversational editing and consistency possible. 3. Gemini overtook the leading chat app. No. It briefly topped a downloads chart. By actual usage, the rival stayed well ahead. A surge, not an overtaking. 4. We know how it works under the hood. No, Google has not disclosed it. Native multimodal, likely autoregressive planning plus diffusion decoding is the family pattern hedged. 5. AI cannot spell, it cannot put text in pictures. That is outdated. Early image models painted letter shapes without spelling words. The newer ones reason about the words first and render readable text in many languages. That is not a permanent failure. It is a problem that got solved, and the fix is the lesson. So step back, because this story is bigger than one app. The intellectual payload is this. The leaderboard is not the scoreboard the public votes with. Google's runner-up assistant did not close ground with a higher test score. It closed ground when a creative act you do to your own selfie went viral. In consumer AI, the real scoreboard is how many people come back, how often and for how long, and the moat is momentum and distribution. An app riding on search, on Android, on a billion-user surface, not a defensible secret. Underneath that, a one-way door for the whole industry. Once a single general model can both reason and generate pixels, the old setup, a chat model phoning a separate image app, starts to look like a transition phase, not the destination. The frontier is multimodal generation as a native act, and zoom all the way out. This was the moment AI image generation went mainstream. Billions of people in many languages, across 100+ countries, suddenly carrying a conversational image editor in their pocket. So the real question this leaves us with is not which model wins the benchmark. It is the deeper one. What happens to truth, to trust, to creativity, when nearly anyone can convincingly edit any image in a single sentence? That is why the quiet watermark woven into every picture matters as much as the magic that made it. Powerful, easy, and traceable, but not foolproof. That is where we are, and it is worth understanding clearly.